And we're live. Back to more Kubernetes magic and stuff in our 18th Everyone Can Contribute Cafe. And today, Nicholas will dive into users, permissions, and much more, I think. So I will just hand it over to you.
Okay. So I think we can start directly. No, don't. From my host screen. Yeah. So we are now on everyone can contribute number 18. So it's like our birthday. So also a little bit the 18th birthday. So a little bit we can also talk about getting promise and getting rights to do something. So it's the right point to get into this. So today we want a little bit to speak about Arbor. So that means literally that we need to look into two important points. So the first point will be a little bit what the most people know is probably under the name authentication. Mostly if you read it in Go or other systems, it's mostly only specified as authn. And if you're authenticated against the service, you want also probably authorized to do something. So this is the other step. So instead of authentication, then we're talking about authorization. And the short form would be auths. So currently, Kubernetes in the past has different models to do the authorization part, but the authentication part was mostly the same. So for that, we will look at first into the authentication part, how it can authenticate as a user, and afterwards we're looking more into the role-based access in the model, so on the authorization part. So which access do I have to get directly into the API? So before that, no, not before, we can deeply dive back into our system. So Max was so great that he provided me the cluster, shared with me the config. So currently I'm as the same user so we can first check currently, I hope it's big enough, right? So everyone can read the screen, or should I make it smaller?
I think it's perfect. Thanks.
Okay. Yeah, so first we can check. I can connect to the Kubernetes cluster, so everything is in place. Most important point is here so that we can see the control plane at least. And this is currently where we're connecting against each other. So for that now, because I don't want to use the same user, yeah, so literally this is the same configuration from last time. So we see here the demo. Don't care about the Nicholas user. I will come later to that. We have our cluster, so we have the namespace and the user. Now what we want to do, I don't want to log in with the standard user, so I want to create my own user, also that at least I can give Michael also a configuration, or someone else that can also use our cluster at least, or can get access to the cluster. So for that, there are multiple ways to do that. Currently, the most common are, when I look into this, is mostly the first would be TLS. So I have a private key and it gets a certificate, and these are my credentials to authenticate against the cluster. So if you're running on a managed Kubernetes, for example, on RKS, EKS, or GKE, mostly there's another concept used for the authentication. I will move it there. It's a little bit finer. So for that, most people use another approach, and that would be OpenID. So in terms of IData token, literally, this is the authentication for IData token, mostly called, used the protocol for that, or the data format for that is JOT, so JWT. And this can be also used. The cool part about this is that currently all the requests going to the API server, so and our API server is capable to do multiple authentication models. So that means when you choose to use TLS certificates for authenticating your users, you aren't, and you want later to add OpenID to that, it's possible. So you can use twice authentication layers, or you can use 3 in terms of, so that you have multiple authentication methods in your Kubernetes. Most reason when you go into production or when you want to use it in the day 2 or day 3 operations, really you should use OpenID, but we will come later to the point why you should use this instead of TLS certificates. But for understanding, I think TLS is a great way. And also, otherwise we need to dig a little bit into the J3S server and check how it works there. So for that, we will come back later. Okay, so luckily, let's create a user. So for creating a user or creating the user for the control plane, first what we need, of course, is a username. So probably I will use my same username. So I will use Niklas, and we need a special one later, the group. So I told everyone can contribute. We will come later to the variables where we need that. And for that, I have prepared a document also. Probably I can hide this. Okay, cool. And move this also outside. Okay, it's fine. So first of all, because we are talking about certificates, most library that is known as OpenSSL, so that you can generate a little private key first of all. So we will start and creating our private key. If any questions you can ask besides that, so I can explain and also do something. Yeah, so in the next step, now we have literally on our system, we have a private key. You can see here, so this key shouldn't be shared to anyone. It should be only local on your system. Please don't share it because I generated only once. It's fine for testing purpose. And afterwards, now we have a key. We need to identify the validity of this key. So for that, we need to have a certificate that can someone trusts me that this is my private key. So for that, we need to create first a certificate request. So it's also called a sign-in request. So for that, we're using again OpenSSL, and hopefully it works again. Yeah, true. So now we have a new file. It's called CSR. So this is the certificate sign-in request. Here you would see all the dates for the certificate. And now we want to, so what we want to achieve now is that our application, or that our Kubernetes servers, because Kubernetes, the API server, has its own certificate authority. So that means you can manage a lot of multiple private keys with the certificates, means to allow our certificate. So that's the reason why we create now a new file that is called certificate signing request. And for that, we will use now the key from our file and so on, and we'll generate a new document. So first of all, we can look afterwards into the file. So when it's generated, we generate now a sign-in request against the Kubernetes service, and now we can also inspect that. So when you type, you can do the full kind, or doing the short handle like Max last time reported, so that you can also generate this. So what we can see now here, I used the name Lily. This name will be used as the username. Afterwards, we can have it also now to see the YAML fun. And literally, we can also see here the username. What usage we want to use? We want to use a client authentication. Really, our kubectl is the client, so that means that we also want to authenticate against that. And so for that, we now need, in the next step, we need to approve the certificate request. So that means we're approving because when we're going back into the files, so when we're checking the CSR, You can see it's currently in a bit condition pending. So that means we are not allowed to use this, but someone needs to accept this. And currently, because luckily we are on the point of that we are system admin with our first user, so we can accept the certificate. So for that, it's straightforward. We can use kubectl certificate approve. And afterwards, we have now approved, so we can check now the CSR again. And now it means so that it's approved and the certificate was generated. So that means really true, we have now our certificate, and now we need to fetch the signed certificate. So for that, we can check the CSR again. And type in Niklas-o-Yammer. And luckily now when we're checking the status field, so every YAML file in Kubernetes has a spec and a status field, and the status are mostly updates of the item. So that means that we now need to fetch this certificate. As we remember, okay, all the credentials are encoded in base64. So that means we need also decrypt that, and then we get the final certificate. So for that, I wrote a shorthander literally so that we can use this. Now I'm fetching the certificate, and now when I check this, it's 509 minus n and dash text, I think. Yeah, cool. You can see the whole certificate literally. And now you can see here is the user group name, the common name, and you should also see the issue. Let me check where. Wait something. What's the issue? Yeah, you see it here. Right, so really you have few issues. So that means it's from the K3S server, it's from our control plane. Now we have a valid certificate to talk to the certificate authority. Yeah, so that means we have now everything in place. We can use these certificates to authenticate against the Kubernetes service. So now let's do it. So luckily, it's a little bit straightforward. So I will set up my kubeconfig to a separate one because my default kubeconfig is a bit different. You have also the option to do that. So when exporting the kubeconfig variable, you can also set this. So for that point, we now need to update our credentials. So literally what we do here is that we will create a new user in the K3S demo file. So when we're checking this, is it YAML? Okay. So we can, first of all, what we did is here now to create the new user. This is currently the data of the client certificate date and also the client key. So here's also the private key. This is also the reason why you shouldn't share these files around the world because someone can get access to that. So for that, we now need to set next to the credentials, we can set up our context. So for that reason, I have now a context, it's called Niklas, and luckily we now want to use this context in terms of, because last time also Max explained that we can use kubectx for that, so probably I can also use this. So that means we have the normal K3S user. So for example, when we're now typing into the namespace, in the same. So we have the default namespace, and when we type kubectl pods, we see the pods. Now I will switch to my user. It's called Niklas. And when I type kubectl pods, oh, we got an error. So now you see the first concept that we currently finished. So what we finished right now was the authentication. So yeah, I'm allowed to authenticate against it. So when I type kubectl cluster info, I should see it's working. Oh, it's also not allowed. No. Okay, so now we need to fix this part really. So what we did now, we finished mostly the authentication part. So we finished the authentication, did set up a private key, approved this against the API server, and I'm now able to use this. But now I need to have rights to do to execute commands against it. So now it comes Arbeit in place mostly. So for that, we can go into the documents. I hope so. The word. No. Let me check. Yeah, cool. So what we need to do now is so that we give our user the permissions, and for that we have really a new concept. So now we will introduce a new type. So it's called cluster binding. And this allows us to get permissions to something. And mostly, we will create this in first place. So, and I will explain it afterwards. So first, because our current user Niklas doesn't have any permissions, I need to switch back to my admin user. And I will add this cluster role binding, and I'll explain afterwards what the cluster role binding really is. So cool. The cluster role binding is there. So now when we're checking it, you can see that we have our everyone can contribute view binding. So when I now switch back into the user Niklas, and for example, type the same command that I did before, for example, kubectl reports, you can now see I don't get an error anymore. I get only no resource font in namespace. So that means we have now the authenticate part solved and auto reauthorization. So I'm allowed to start some commands. It's like true. Now we are in a true way. So, but now check why it was. So I will go back into the admin account. Is there a shorthand for cluster role binding? 3 letters or something, right? Because CRB doesn't work. I don't like to type everything. So when we're now checking this, we're looking against YAML again. Don't look at the managed fields; they're not important. So literally, what we have here is like the role reference. So that means a cluster role, and currently all the subjects, so all people or all persons are currently or groups are allowed to do this. So luckily, because I created the everyone can contribute group, every user in the everyone can contribute group can use the cluster role. So, and a role, literally, or cluster role, when we look into this, it's a standard role that's provided by Kubernetes by itself. So it's mostly built in an every conformant Kubernetes cluster, and there you can see a lot of commands and a lot of actions. So what you can see here are now all the rules currently that our users are allowed to do, all actions. So because we are talking with Kubernetes against an API server, we have the same pattern literally. So it means we can allow all the API groups. So it means from which version it comes. So luckily we can also see now that in the view role, we have the cert manager. So I'm allowed to see certificates and I'm allowed to start to see certificate requests, issuers. But for example, if I want to check if I'm also capable to start to get pods, but I'm probably when I check back into my user, because I have a rule view and check this back with, for example, starting a pod, an application, you see also forbidden. Because with a view role, we have only access to the API server that we can get only information about the Kubernetes meta server, or getting about all the objects that are currently allowed to, but I'm not, for example, allowed to start a pod. So because this is a different verb, a different action that we need to do. And for that, we will come later to the point where we also create this, so that I'm also allowed to do that, but I will come back into the point. Mostly, I go back into my prepared view that I prepared already. So literally, we have now seen through 3 items. Let me check where I framed it. No, we take here. Yeah, cool. Take this. So really what we did now is we have our group developers. In terms of our group was everyone can contribute. So this was coming from the certificate. So it's the organization unit. Now we created the role, the cluster role binding that was called, let me check. So that we have here the view binding, and the view binding is the connection between the role, the cluster role, and the group or the user. So this, we are having here currently 3 items to do the authorization. So that means this is also the mentioning why it's called ABAC and not, before that it was ABAC. So attribute-based access control. But now we have ABAC, so we have roles. So roles can contain multiple rules or policies. And we are getting the relationship between a cluster role or a Kubernetes role by itself with a role binding, so that this role binding knows which roles can be accessed to the following group or user. Yeah. So coming back. So now we talked a little bit about the concept of cluster role and cluster role binding. So probably you asking why I know currently which view role we used before or not. And for that, we have currently default cluster roles or default roles that you can use. And for that, I use the standard view role. So I would also recommend to start first with the standard roles, and then you can extend it afterwards to your own if you need that. Yeah. So coming back, probably you want also to start a little bit about now starting your pod at least, and we're coming now to a new concept. So luckily now let me check where my stuff is. So now we need, instead of so what we want to do now is we want to create a new namespace. So literally, because we don't want to use the default namespace, we want to have our own namespace, so where we can do cool stuff. So for that, we're creating our own namespace that we call everyone can contribute. And now when I'm now when I switching into that, I will change the namespace, contribute. Cool. So we can check here, nothing is currently running. So also the same, we have no roles there, we have nothing there. So for that, now we will add a role literally to that point, a new role binding. So, and now what we did is, when I go back now into my Niklas user, I will come later to the convention of that. So for example, when I start now here, the Alpine the Alpine image to test it, it doesn't work. So, but when I now switch into the everyone can contribute and start it there, it works. So the main difference, what we did now was we don't use a cluster role binding, we used a role binding. So what's the difference between that? Cluster roles, or everything with cluster prefix, is about the whole Kubernetes cluster. So it's placed in every namespace. You can do everything in every namespace. But if you have only a role binding or a role, it's only contained into a single namespace of Kubernetes. So that means you can give, for example, you can have multiple namespaces or also multiple teams. Each team has its own namespace and can do things that they want to, but without harm the others or adding new resources or something like that. And probably we can also communicate outside because we don't have network policies in place. In the air cool, we can now work as an own developer with our own user. And that's really curious. So that's really the authentication and authorization part about Kubernetes. So, but now we're coming a little bit to the point. What I wanted to point it out is now probably when I switch back to my KS3S demo, for example, we say, okay, I don't fine anymore with the user Niklas. I want to delete that. So when we now delete our sign-in request, so now we delete the sign trade. Now probably I switch back into the user Niklas and start a new pod because I don't test 2 or something like that. You can see now what doesn't work with TLS certificates at least is you can still authenticate against the API server. With TLS, you can't revoke the access, at least. So the authentication can't be revoked. So what we only can do is we could revoke the cluster roles and the cluster role bindings, and also the role and role bindings. But currently, the user has still can still authenticate against the Kubernetes service. The reason from that is because Kubernetes doesn't put in place a certificate revocation because it would be a tremendous amount of work to do that. And that's the recommendation why you should use OpenID Connect or some other tools to do that for the authentication there. So we can look a little bit into the part where you can, let me check where I wrote it. So roughly that's the line, what it says. Yeah, so really we have, so you could also use a static file token, mostly, but it's what mostly recommend. It's like a BR token, so that's the dot place, and also mostly an OpenID Connect. So it means like you have also the option with OpenID. And how OpenID is working currently, it's like a little bit different to that we used before. So for that, we can start first of all as user. I log against the identity provider. So our identity provider could be, for example, GitLab.com, or it could be another service, for example, Google or something like that. So every user from Google can log in into can get authenticates against the Kubernetes service. Or you can also specify by the OpenID protocol, you are also allowed to, for example, provide only a subset of OpenID users by the identity provider can. For example, the everyone can contribute group can do that. Afterwards, the kubectl calls identity. It will be added to the identity provider, the token, and then in our kubeconfig, we don't use TLS certificates anymore. We use these BR tokens, and then finally authenticates against the API server. So the OpenID flow will be executed mostly, and afterwards the authorization part will be performed. So that means which roles I have and so on, and then the user gets the final feedback. Yeah, but for that, we need now a little bit to decide if we want to do that or not, because for that we need a little bit to hack, because we need probably to change the API server to allow an identity provider, because this is not built in by dynamic, or you can't change it by dynamic. You can only determine it by boot time, by bootstrapping the cluster, or you can probably also fix it afterwards. It's also possible, but mostly it's like that you should use this when it started, yeah, when you bootstrap your cluster. So, but before we go into the OpenID thing, I would say that probably someone has questions, or we can talk a little bit about it. What you don't, if I probably can explain something for that. No, no one.
To be honest, I'd like to see what you are showing currently.
Probably I can. Max, did you provide my key? Yeah.
Yes, I uploaded it on the server.
Okay, so let's check. First, I need to check only which key I have on this machine. So hopefully, that can use it. Yeah, but I need to check on the machine that I currently have by my side.
Okay.
I don't share anymore, right? Yeah, it's fine. Okay. I hope this was it. Okay. Let me check. Do you know the default user that that we can use here?
Root.
Okay. I will check. Why doesn't it work? Okay.
What are you doing currently? Maybe verbalize it.
Yeah, currently I'm checking which key I have on my machine to check if I can connect to the machine. Yeah, okay, cool. I'm fine. I'm getting in there. So it's fine. I need only to
You're talking about SSH keys, right?
Yeah. So okay. I'm on the machine. So now let's check. So hopefully we need now to debug a little bit. I don't know where it's placed. Okay, so that will be a little bit more interesting than I thought.
I think it's in Rancher.
Search. Okay. Here's the config, and do we have probably static node there? No. Okay, how does it start? It's container D, right?
I think so, yeah.
Woo! Let's check. Wait. So, need a bit to debug. With div64. So, hopefully.
You should also be able to run the K3S binary from opt/opt K3S, and then I think it has subcommands to talk to Kubernetes.
Ah, yeah, cool. Yeah, okay. So let's check. I will remove first the pre-CTL. Now let me check. I want to use those /opt. I'll check what the third command can do for us. Does he provide? Okay, this starts with server. So we can check for pre-CTL. So what I want to do right now is I want to check currently which container are running, because I want to check if the API server is running. It's probably in a different namespace. Let me check the system. Where it is. Okay. Okay, K3S works a little bit different than the normal upstream to see that. So let's check.
You are looking for the API server pod? Or?
Yeah.
Yeah, I think it's not running as a pod. It's the K3S binary itself opens the pod, I think.
So let me check how this works. Really, okay, coming back to the point. So what I want to do now would be I want to provide an identity broker, really. So that means DEX will allow us to connect to an OpenID identity provider. So for that, my intention is really to use for that also GitLab, so that everyone can contribute group can access really our Kubernetes service and authenticate against that. So that would be the main idea mostly. For that, let me change if I wrote this down. Because I noted there. Yeah, cool. So for that, there's a cool point. Really, what we need to do is we need to provide DEX in the Kubernetes cluster and also Gangway. Gangway will be used later for the OpenID for the users, so that we can easily generate our OpenID client. So yeah, now we need to find out how we can set the OpenID for the Kubernetes API server. Otherwise, our Kubernetes API server doesn't trust the GitLab, and so then we can't authenticate against the service. So let me check how it works. Across it. My assumption was that K3S uses static parts to do that, because it's quite normal way. No, that's everything not what I'm looking for. No, also not. If I need to specify something. It's only vanilla way, right? So certificate stuff, token method, OpenID connect. It's the same flow. Yeah, now I'm currently stacking a little bit because okay. Can specify for that way. Now I need to check how to do that. Oops, sorry. So for that, is it possible, Max, do you know it probably, that we can restart the K3S server?
Yes, you can just restart it without any issues. You can, it's a systemd unit, so you can systemctl restart K3S.
Okay. Yeah, I want.
It's a typo, systemctl.
Yeah, sysctl, I think.
Sysctl, kernel.
Oh.
Okay. And then we need to patch this, I would say.
It's deployed by our Ansible role, so it's just in etc systemd system K3S.
Probably it's, let me check something first. Okay.
Maybe we can talk about what are static pods and not dynamic pods in the meantime while we wait or something.
Yeah, we don't wait. I need to check currently something. What it is? Actually, it's with Kubernetes. No, also. Okay. Yeah, currently, by default, if you are using Kubernetes, so luckily, I can explain it a little bit what a static and there's no difference between a static or a dynamic pod release. So what you have typically in your system, if you are deploying with kubeiam or with other tools like mostly a lot of other tools supports the same way. It's like, so what you can use is you have a root path under your node. So actually everything from Kubernetes goes into just check the normal font. Goes into etc Kubernetes YAML into Kubernetes etc Kubernetes.
Manifest, I think.
Yeah, manifest will come later. So, and for that, when you put something into etc Kubernetes manifest, these YAMLs or manifests will be deployed automatically. So, and what you can do in the folder is you can create, for example, like my pod YAML, and you can put this into etc manifest. And then by automatically when the kubelet starts, so it's a feature of the kubelet. So it's not like from the automatic Kubernetes service. So that means that automatically this pod will be automatically started. And by default, if you're using another installation method like kubeiam, the API server, the etcd server, every component or core component by Kubernetes will be deployed as a static manifest into the etc manifests, and then will be executed dynamically by the kubelet. So that's the reason why it's called static manifests mostly, or static pods. Or you can put everything there. So it's like that you have for bootstrapping. So that would be also come to the theory that you can do Kubernetes without config management if you're looking a bit forward. So because you could also write everything to containers into pods and something like that, and then start them on Bootstrap and automate all the stuff. Yeah, so now let's come back in the meantime. So I need to check. Okay, you can set it here. So for that, it was an etc, right? Systemd. System.
Yeah, there should be a file K3S.
No.
Let me check. We do this in Ansible.
I got it. Okay. So now I need a little bit to. Okay, I'm not root. What? Why it's read only?
Or it's you can probably just write it anyway with W exclamation mark. Yeah, you can still write to it.
Okay. Now we need to look back into the commands that we need to use. Okay. I'll make some notes there. So it goes a little bit faster. Into this. And now didn't note it down, right? But I noted it down into the mirror board already. Cool. Let me check. So really what we now use, we use our own OpenID issuer. So it means like we would deploy Dex under Aufen, or we could also use Dex. It's like fine. And then we need to have the Dex client ID. This will be generated afterwards or not. So let me check something first. It's only called server. Or is it called art? Okay. We can test this. So it's like cross. I don't have a client ID. Where did the client ID from? Let me check. Everything here. Sorry, Cortex. Cortex. And going back. Okay, I will deploy Dex first and then we get it. Okay. So literally we use like last time, we also use a Helm chart for that. So I prepared everything. So luckily you can see here the Dex configuration. So Dex has also a Helm chart, and we can generate the configuration. So in the connectors part, so this is the real connection to the GitLab. So Dex only proxies the GitLab for the Kubernetes API server, so that you can have multiple OpenID connection services. Yeah. So let me check. Now going back. Let me check where it was. No. Let me check. Here, now the perfect list. Okay. Okay. So, and we hopefully deploy our Helm file. No. Upgrade, just install. Every time it's upgrade, so our release would be dates, it would be the chart text, and then we start with this release YAML and also this install. There we go. So because Helm doesn't create automatically the namespace by default, so we create also the namespace before. Now deploying it again. And okay, so we need also to switch to namespace.
So maybe just FYI, so you can do a Helm upgrade minus create minus namespace. Then Helm will create the namespace.
Yep. Yeah, I think the order was the reason, but didn't I change it? The URL already? Oh, I didn't save it. So do it again, Sam. So now hopefully we have our decks in place. Yeah, cool. And now we can check if it's available. So for that, first we see a page not found, or you would say, okay, the service is at least reachable because we get an HTTP 404 page not found, but now we can also check if the service is working because we're using OpenID, the standard protocol. You can also try well-known OpenID /configuration. Yeah, and there you can currently see the whole OpenID information about our service. So that means literally also OpenID provides a sign-based approach. So for that, we have also the signing keys here. So that you can also see that these keys will be used to sign the JOT token. So because when you're going to JOT, you need also to sign the whole key, and for that it's the reason why you have also JVKST. Yeah, so we have now DEX in place. Now we need to bootstrap our Kubernetes cluster to use that. So for that, I need to find my notes where I wrote it down, but I didn't get the client ID, right? Yeah, so now we need to get client ID. So let's check into the secret. And probably there we have the DEX config. Or let's check the logs of DEX first. So let's start. Kubetail is the same like a service. Yeah, we will skip it. We will see if it works or not. So let's check if it works. Because we don't use also not SSL, we don't also need that. Hopefully. And now we need everything in one command line because I'm lazy. Okay, and then we have stuff that we don't need. Okay, that's the stuff we don't need. So let's use this and connect them back to a machine. So, and now editing the system number. Now we should copy it. And hopefully restart. And see how it works. Oh, it looks good. Currently, I don't see the commands. I don't, because it's in a different C group. It didn't save. What?
You might have to run systemctl daemon reload for it to reload the new systemd unit.
No, the service file wasn't updated. I think you need to.
Even the file. Oh.
I think
Yeah,
the file permissions are wrong. It's a read-only file. Change it to 60060. So VI did not. Okay, yeah, execute is not necessary, but now you can save it. Because I think colon, WQ and exclamation marks don't work. You need to explicitly have permissions or be magic root.
I'm going to check if we don't need this answer. No.
And probably Max can immediately add that to the Ansible role.
Yeah, can do that.
Thanks. If it works, I have.
Ich think we need. Yeah.
I'm currently trying to understand what we're doing now.
Okay, so what we do now is, because we have now the Dex service and our API server, so I can draw it hopefully afterwards. Otherwise, we do it next week. Then I figured out how it works. So when we now starting with kubectl, restart KSVS. No, okay.
Deprecated.
Sure, client ID should be together. Probably I missed something. So we have the API server, we have the issuer URL. We missed the client ID. So what is the default Dex client ID? Let me check. Is it? Wait, let me check where it was. It's called GitLab. And now we need the command bank. So what we're currently missing is that we're missing the open ID connect client ID. And then it's called GitLab. So I think the order of commands is not important. Let's do it this way. Do I need to reload the daemon?
Yeah, you need to do the system daemon reload again because the service file changed on disk. Systemctl daemon reload, bang, and then restart the service.
No. Computer says no. Check. Okay, then it's a different topic. Yeah, that would take a little bit more time. It
doesn't like HTTP.
Yeah. Now we need probably I explain in a high overview what we want to try to achieve. So I will draw a small diagram, and then we will fix it in the next week. Hopefully, we will fix it in the next week. I can show it to you across. Yeah. So coming back to my mirror board. So let me check we have some place for that. Yeah, cool. So so actually this is our Kubernetes cluster. So and now what we can send out some back Kubernetes into packets would be FM. Okay. No, this wouldn't. No, also not. Let me change. So okay. I will zoom back again in. So so currently what we have here is so we have currently DAGs in our Kubernetes cluster, and we have our Kubernetes APIs. So yeah. And what we're trying to achieve is that we want to connect our API server literally to GitLab, and I will change the colors a little bit so it makes more sense. So, and for that case, what we need to do is, because the API server can speak directly with GitLab as OpenID provider, we need to tell the API server first, in the first step, go to DAGs, ask there for the user, and afterwards, DAGs will ask, instead of will ask GitLab for the final user so that I can authenticate against that. So, and currently as user or as person, what we are doing is we are only speaking mostly with I'll use another color. We will speak only with the API server. So we don't know that DAGs is there, that we don't know that GitLab is there. Literally, we know only that we want to authenticate and against GitLab. And so for that, we have a user with kubectl. And for that, we do this flow. So literally, our identity provider is, like I talked, is GitLab. So it's called the IDP. And we want to authenticate against GitLab with that, so that we can use this user with a beer token instead of TLS. But for that, because it's a security protocol, it's an authentication protocol, it requires security. For that, it shouldn't be good that we speak HTTP over that, because then probably user information could be leaked over the internet. And that's also the reason why we need to speak this in some secure ways. So for that, we need to do only HTTPS ports here. HTTPS, and also here HTTPS. And for that, we need to leverage, in the next week, we need to leverage DAGs with an external, with the Self Manager, so that DAGs can speak HTTPS, because then this can also be verified. And then we have the option to use all the users there to authenticate against that. And mostly we can also, the cool part about this is when we're looking back in the DAGs documentation, we can also specify, like before that we specify our everyone can contribute group, we can also do this in GitLab. So we can say use only the group of GitLab, only everyone can contribute, so that we also restricting the scope, who has also access to that. And then we can do the same Arbeit again. So that would be the outcome of next week, I would say, if everyone is fine with that. Or probably then we need to take at least an hour, I would say, to solve all the stuff. Yeah.
I think that's a great idea. The thing which I need, or probably others also would appreciate, a recap what we did today, because
Okay.
I think there were many. Not next week then. So we do a little recap what we did, and then we are aiming to fix the HTTPS.
Yeah, mostly I can start with a short recap what we did today, and mostly I repeat it next week. So already what we did is we did the authentication part, but we did this only with a TLS certificate, so with a private key in terms of instead of a real username. So we don't use an external user, and we did the authorization part with airbag. So this is airbag, literally. And we created different authorizations models. So we used a row binding to get access, for example, for our developers group in the everyone can contribute namespace, and also the same for the cluster role. So that also our admin has general access to the cluster. Yeah. Mostly next week, we will focusing on the authentication part of OpenID with K3S. Yeah. That will be mostly next week then. Yeah.
Okay. Are there any other questions from the group?
Was it too fast? Was it too
much?
Too much? Okay.
No, not too much. It was a lot of to capture.
Yeah, but we'll repeat it next week in the first 5-10 minutes, and then going back into the OpenID topic.
And we also have the recording and the live stream to like scroll 2 times fast now. The blog post will be ready soon, and probably, yep. I'm a little overloaded myself right now, but I think next week will be fine. So thanks a lot for preparations and all the nice things.
I can also write to the blog post. I can also give you all my commands because it's written in Markdown. I can easily copy paste it.
Okay, yeah, I will update the merge request, which I'm working on currently, and then assign you. That's perfect.
Or adding it to the repository there in a good place. It's also fine.
Yeah, we'll try it out in our new Discord channel.
Yeah, okay.
Okay, then we'll say bye-bye to